I'm John Hargrove, and I'm just going to provide you with a very brief introduction to the exercise you'll be carrying out, where you will be fitting models to data relating to changes in HIV prevalence in Harare, Zimbabwe, between about 1980 and 2015. This situation was originally put together by myself and Brian Williams. But you'll see there are other people involved in putting together what the models you're going to be using. The data were basically derived from Harare antenatal clinics. So what happens is that women who are coming in for their first checkup when they're pregnant are tested for HIV. And over the years, it's become possible to build up a picture of what has happened with the prevalence, HIV prevalence amongst pregnant women in Harare who are attending antenatal clinics. And what you see here is that well, in 1980, there was essentially, there was no HIV. There wasn't an awful lot of monitoring of what was happening during the 80s, but in the 90s and towards the end of the 90s, got to the point where there was quite a lot of monitoring, and thereafter one can see the pattern very nicely of what's actually happening in the HIV prevalence. You see it went up to alarming levels towards the end of the 90s. And then, for reasons that you're going to be exploring, the HIV prevalence declined really quite rapidly. So what you're going to be doing in your modeling exercises is trying to mimic these things using models to see whether you can actually fit these data. So the fundamental data relate to what's actually happening with HIV prevalence. In this exercise, you're going to try to model these changes. Now, in addition to the HIV prevalence data, we've also got data on the mortality in Harare. And what you can see from here with the dots at the beginning is that at the end of when the war, the independence war finished in 1980, there was a big influx of foreign aid into the country, and medical services very much improved. And with the end of the fighting, there was a big reduction in mortality, and it seemed to be falling off exponentially in Harare. But then HIV came along, and you then saw very big increases in the mortality. And the mortality, you can actually then work out what proportion of the mortality was actually attributable to HIV. So we'll be taking that into account as well. So mortality in Harare declined in the early 80s until the effects of the HIV epidemic made themselves felt. We've also got a small amount of information on the way in which HIV incidence changes with time since 1980. Incidence, for reasons that you're perhaps familiar with, is much more difficult to estimate than prevalence, so we don't have as much information on that. But we do have some. And so if we look at this here, this is just a thing put together where you can actually see the increases in or the changes in prevalence, which are in the blue, and the estimate of how we think the mortality has changed as a consequence of HIV there. And then this is sort of just a couple of estimates of incidents that we've got to play with, and you're going to be using those. Now then, the spirit of the modeling that you're going to be doing is that you're going to start with the simplest possible model, with the smallest number of parameters. And you'll not be surprised to find that with a very, very simple model, you're not going to get a perfect fit. And the idea is that when you do each of these fitting exercises, you try to decide, and we'll lead you through this process of trying to decide why it is the fit is not so good. And that can be for a whole lot of different reasons. What you'll basically be doing is just trying to fix one thing at a time, and actually moving forward and moving forward to a slightly more complex model, just adding one parameter at a time, and seeing how that improves the situation, then seeing what the problems are there, deciding what the next parameter is that you might want to add to the model, and just go forward in this fashion, just adding one parameter at a time, keeping things as simple as you possibly can, but in each instance saying, well, this doesn't really work, and this is why I don't think it's working, and let's try and add a further parameter. Once you've got it to the point, and there'll be about a 4 or 5 step process, you'll get to the point where you can actually get quite a good fit to the data, and it might be that, well, maybe you can think of further ways of improving the fit, but we'll just take it to a certain point. And once you've actually done that, then you can think about what it all might mean. Now, we have actually worked on this in the past, and there is this paper which where Brian and I were the sort of leading workers on doing the analysis, and it's published there, and you will have access to that paper, which you can read what's actually going on. But the idea is that you should actually play with these data and see what sort of fit you can get. Now, the modeling behind these analyses is based on the systems of differential equations, but you don't need to worry about that. You don't need to worry about the mathematics. That's all going on in the background. What we're going to basically be doing is giving you various models of this sort, which are sitting there in the background, and you're simply going to be varying the parameters for different model setups to see how well you can fit the data. Now, the modeling, again, it's all done in R, but you don't need to actually know how to use R in order to do this. You're going to be using what's called a Shiny app, which was developed by Juliet Pulliam and by Carl Pearson. And you essentially need to just play with different parameter values, find out where, how well you can fit the data given a particular model setup. Convince yourself that if a setup is not good enough, it doesn't make any difference how you change the parameters. You're never going to be able to get a perfect fit, and then move on to more complicated models. Okay. The full instructions for running the Shiny app are provided. When you come to do the exercise, you'll be led into how it is that you set up the RStudio and get in there, what you put in, and how you access the models. And it's a lot of fun, and you can go through all of the data for Harare. What I should say before I finish is that if you finish working on the data for Harare, you can then, there are other data sets for Uganda, for South Africa, and you can play with those data, and you can see that actually things are really quite different in other parts of the world. For instance, in South Africa, the HIV prevalence hasn't come down the way it did in Zimbabwe, and you might like to think about why there are differences in the situation. Okay, well, good luck and enjoy.